Okay, so welcome to my talk, Angular Concurrent Mode, highly performant and non-blocking UIs. Today's I present from Tahiti, which is like 12 hours in the past from Tel Aviv. I hope that the connection will stay. And I will not lose time, I will go on. And I will give you a small hint on what the talk is about. This talk is about rendering, about client-side rendering in comparison to server-side rendering. And if you really want to know which server-side rendering I mean, yes, I mean the really good old server-side rendering with PHP and MySQL in the backend. So in comparison to that, I will talk about the client side, and I will not talk about the stack or the framework. I will really talk about the rendering process itself. To give you a first sneak peek how rendering in the browser works and how I try to fix that, let me show you a quick demo. So I have two applications here. One of them is a real-world application with movies, and another one is a demo application where I can really stress out the problem. Let me go to the first one. Let me open up the performance panel here on the left, a little bit bigger. Yes, so, and let me hit the record button. And then I will navigate between two links here, back and forth, and then I will stop this recording. The recording takes a little bit of time, but when it is done, we can see a very specific problem. If you don't understand flame charts, don't worry too much. We will go into detail with all of the stuff that you see here. But for now, please watch out these red bars here that you can see at the top whenever I navigate to a new page. And you can also, if I zoom in, recognize this red bar over here. There is a task, and this task is marked with a big red bar at the end and a small red triangle. This is called a long task. This task here took nearly 300 milliseconds, and in those 300 milliseconds, our screen was frozen. Our screen was blocked from user interaction, and this is a really bad thing. I can stress it out a little bit more when I navigate to another fake application here. And I can do that again. I hit the record button here, and then I hit on the native element, and then it really freezes totally. This is a little bit more overstressed example of a lot of elements and a big list. And this is even more blocking. I guess this blocks over 1.9 seconds. Let me see. 4.7. So in this case, it was 4.7 seconds of blocked UI just because it was a huge list. And this is the today's problem that I want to fix for you. And I want to present a solution. Let me first introduce myself. My name is Hladky. I'm a trainer and consultant with the focus on Angular and especially on performance. And now back to the topic, let's talk about rendering in the browser and responsiveness. And first, let's go to our good old server-side rendering. I call this respond on request, and I will tell you why. Well, imagine you have this HTML site, and this server sends you a rendered DOM structure to the client, a list. And then if you remember in the good old days, you had those small tiny buttons next to the list that you could move items up and down. So when you want to sort a list, you would have to click the button, send the request to the server, get the newly rendered list back, and then you could click the button again, send it to the server, render it on the server, and you get the newly rendered list from the server back. This is quite annoying, or it's a pretty old way of doing it, but this is where we are coming from. If you look at this graphic on the left side, you have the event, and if you click a button, you could trigger, okay, you could execute work. In this case, we don't execute the work right away, we just trigger and schedule the work into the future. So this is our package of work that gets shifted in our case here in the next animation frame, and when the animation frame hits, later on we perform our task. This is how we would schedule a specific task in the browser. And compared to our calendar, the gray boxes are the days, and work, the blue dots here are those flame charts, are these marked with this executive text. This is the part that I want to schedule. There are many schedulers in the browser. We have set timeout, macro tasks, post message, request animation frame, request idle callback, and post task. A lot of different methods that you can use to schedule work, to chunk work. I'll show you where they would end, and you can see, depending on the different methods, they land before or after the paint event, which you can see here in the middle. And this is one fundamental piece that we need to understand when thinking about non-blocking UIs and client. The main thread and its frames is the next chapter, and here we basically go to in a little bit more detail on what the main thread is and what a blocking task is. First of all, let's talk about tasks in the main thread. If you remember the calendar and the calendar's unit, we could look at these units and we see that one unit here is a day. But of course, we could also go even more detailed. We can zoom in and then we can see that we can have units out of 10 minutes. I guess this is most probably the shortest time that I would manage. And these smallest units of times are tasks. And I cannot really do anything else while sitting in one of those tasks. I really have to finish those tasks until I go to the next task. How do those time frames, those smallest pieces of time, look in the browser? You saw it maybe before. These are those gray blocks here marked with task. And every single gray block is one piece, one unit of work that the browser has to process, and then the next thing can happen. For example, user interaction or more work. So those are the smallest pieces of work in a browser that you cannot really skip. You have to perform that after another. As we now know what tasks are, how scheduling works, I can give you a little bit more information on what a frame drop is, and this is basically today's problem. A frame drop or blocked UI is marked in the browser as red. You can see that here in the diagram, and this is, as I said, a very, very bad situation, because in that time the user cannot interact with the website. The user cannot do anything else but waiting and waiting until the browser is done. So to understand what a frame drop is and how you can produce a frame drop, let me give you some examples of my own life. Frame drops for humans 101. So what could I do to produce a frame drop in my life? Well, the first thing is I have work to do that takes longer. The talk takes a little bit longer than I expected, and then I have to push the next talk that would be after me in the future. So the other person cannot do anything, also the audience cannot do anything but listening to my talk until I'm done, and then the next talk can start. And this is not really good because we have an overlap here. Another thing is I can schedule work in the future, and then I could schedule this work at the same time, like let's say a meeting. and the same day at the same time where another meeting was scheduled, and then it collapses and I again produce a frame drop. Or one of my most favorite things how I can produce a frame drop in my life is when I estimate projects or small tasks, right? So what I normally do is I look at the task, I really calculate how long will it take, and then I think it will take maximum an hour. And for real, when I start the task and I process it, it takes so long that I do not even see the end of this blue box here. So this is a frame drop in real life. And let me show you how a frame drop looks like in the browser. So you remember the gray boxes, right? And one of those gray boxes is called a task, a unit of work that you cannot really split into two, and while this work is ongoing, you cannot do anything else. And a frame drop means a task that took longer than 50 milliseconds. I don't want to go too much in detail on the 50 milliseconds. I have a different talk that is focusing more on render performance and in detail browser APIs. But just that you know, this is the time that Chrome and also the long task API determines as too long. And within that time, you cannot really interact. So 50 milliseconds are good, and everything else is in addition to the 50 milliseconds, which is very bad, which is a long task. The work present in this task here are two different things. On the left side, we have scripting work, and on the right side, we have recalculate style or browser render work. In this today's talk, I will focus only on scripting work because I have different talks that will focus on recalculation styles and other layouting tricks. For now, we will just learn how to jump around, how to deal with scripting work. How to deal with scripting work? Well, with scheduling. And as you can see in this small graphic already, we have a small queue of pieces of work, and this work gets processed one piece after another. I can cancel work and I can prioritize work. Through our research of the RX Angular team, we did a lot of different things in the past 1.5 to 2 years, and one of those really good outcomes was the RX4, a structural directive that was basically born as we analyzed the performance bottlenecks of lists in Angular. Lists rendered normally with an ng4 structural directives, especially nested lists, are one of the least performant things that you can use in Angular in general in any framework. And if we look at the native implementation, we see that every single list item in this list has to get processed in one single task, which means there is no way to stop rendering and do anything else. In the small flame chart here on the right, we see that a bigger list or a list with a lot of expensive list items will block the screen for a long time, and this leads to very, very bad user interaction, especially on navigation. This is the stuff we saw before. Another real-life example on what could a really long list cause is this picture here. As you can see, this is a tremendous, huge blocking task where the screen is frozen for multiple seconds. Really, really bad experience. And this is quite common in bigger applications, especially if you don't really care about performance. You will hit those bottlenecks very, very soon. What we did is we made a case study out of it. We said, let's create a list. Let's create a small table. The table has 5 cells and 10 rows. And then we initialize this web page. We click to update every single table cell 4 times in a row, and then we start an interval to update this table cell as fast as possible. Here at the top, we have the flame chart overview, and we see that initialization is fully blocking. Every click for an update is fully blocking, and especially when we really demand the browser and we run this interval as fast as we can to update, we also see every single update blocks. Here, another close-up on our blocking tasks. And this is, of course, very, very bad. What we did is we came up with strategies where we could say, okay, let's render the list items, but only as many items as they would fit in a task that is less than 50 milliseconds. And if the next item would take more time, we stop work, we schedule the rest of the render work into the future, and then we go on with this rendering stuff in the next task. In between, the user always can click, drag, type, and interact with our page. This means it is really a non-blocking UI. In our case study, here visible with the list, we replaced the ng4 with our structural directive that implements concurrent mode for Angular. It is called rx4. It's present in the Rx Angular library that you can download on NPM. And on the left side, you have a small, tiny flame chart that already teases what we did. And here you can see, no matter how big the list would be, we only render as many items as they would fit into a single list. And they would fit into a smaller task. If we have a close look on the case study for this demo table here, we see that with this technique and only 2 characters of code change, the initialization is fully non-blocking. Every single click in our UI is fully non-blocking, and with the interval, where we have like the highest stress momentum for the browser, in this case study, we see that even between those updates, the browser has pretty much no frame drop at all, and we have really, really smooth interaction and updates. This is incredibly cool, and we basically wrote down everything needed for this in our GitHub issue. So if I open up the GitHub issue and quickly show you our research paper, you can see that we really wrote down any single bottleneck. I make it quicker now because it's a long document, but here we discussed all the bottlenecks in the RX4, what features we had to implement, what we already did, what challenges we had to solve, error handling, and then, of course, the comparison of all those scheduling. This is only one example where you can use Angular concurrent mode. Let me give you some more examples. Before we go on, we basically get a little bit more details, and then I can demonstrate some more coding. So this is basically the comparison again, because it is so beautiful, the difference that I cannot stress it enough. And if I click on the next page, I will elaborate how we did that. So at the top, you see the native Angular implementation, and the blue boxes is work. Consider a blue box as one item in a list, or as one component in a page out of many components. The gray box, same as in the flame charts of the browser performance tab, is a task, means a time where the browser cannot do anything else but processing the work that is present in this specific task. And at the very top, in red, we have the highlighted area where the task took too much time. And this red, you already know from the flame charts, is a frame drop. At the very bottom, we see the implementation of RxAngular. RxAngular implemented something that's called Concurrent Mode, and this is a technique where you basically can tell Angular's change detection, but not only Angular's change detection, also pretty much any work that you want to perform, that it should get performed in pieces that are smaller than 50 milliseconds that will not produce a frame drop. And with this technique, if you look here, we basically take a little bit longer to perform all those work packages, but in between, our user is always able to interact with our website. Our user can always click, drag, tag, or scroll our website, and this is what we need, especially on mobile phones where the performance is really bad by default, I would say. Those techniques really help us to get a better web vital score, a better ranking, and also a better user experience. Let me show you some demos before we go on. I have this Movies app. This Movies app also exists in React, by the way. Identical layout, identical content, identical HTTP requests. It was a small performance battle. We will publish our work on that in the future, but for now, I will show you only a little piece, the piece where we applied concurrent rendering to this app. As I already showed in the flame charts, when we look here, and I will try to hover so that we can see when I click the mouse and the content switches, those red bars appear, and then the images render. And if I click the mouse again, the other menu item, another red bar appears, and then after the rendering is done, the page shows the update, and I can again interact with my website. Let's zoom in a little bit and have a closer look. Here we have a 300 milliseconds blocking long task. And if I try to analyze it, nearly half of it, so 150, more than half of it, is caused by scripting work. The other half, and this is a trick that I will not reveal in this talk, but in another one, is caused by recalculating styles and layout, which will not get solved by today's implementation, but only the left part. And if you can look at this pattern, it's a very, very significant piece here in this task. We already see that there are a lot of different things performed in a row. I can try to go down, and maybe I can also see that we have here some components that gets rendered at the very bottom. Here, those lila, purple, light purple boxes are components that get rendered. So we see that this work here gets executed over and over again. We have a tick, and we have a tick changes. It tells us that in this place that the browser performs change detection, not the browser, Angular performs change detection. So let's jump into our website, into our source code. Let me try to zoom in so that you can properly see everything. And I will do two things. First, I will go to the movie list and I will zoom in. And in our movie list, we see this ng4 here. This ng4 takes an observable, in this case, trackby just to have a little bit better performance. But as you saw, it's not enough. We still have these blocking frame drops. And what I will do is I will refactor this list to get non-blocking. I will do that with a library that's called RxAngular, RxAngular/templates to be more specific. And this library provides us a structural directive that is called rx4. And the rx4 directive enables us basically, now I can remove the async pipe, to pass observables directly. As one thing, this is the developer experience that got better with this directive. And the second thing is, as I told you, under the hood, it serves really, really intelligent way of rendering. with this list here and with another list in my app shell, which is present a little bit more down. Let me search for ng4. Here we go. I can also rx for that, and I can remove the async pipe. With those two tiny changes, really characters, I will do the measurement again. Let me make it a little bit smaller. Let's see if it works. Okay, it works. Very good. I will start recording. I will click on one item, click on the other one, click on one item, click on the other one. So you see, I'm navigating back and forth between those menu items, same as I did in the previous recording. And if I now look at those navigations here, we see that when I click, and this is the case here, the new items directly pop in, one after another, the images load, and the items appear without any blocking task. So I can really zoom in into this piece here, and as we can see, the click here took 35 milliseconds, which is really amazing. It could be a little bit better, of course, like something under 10 milliseconds would be optimum, but 35 is still really good. And then the whole list gets initialized but not rendered at once. And here we see that in one task we perform rendering of some list items here. Again, we see that it changes 1, 2 times, and then before the task gets blocking, we schedule the rest of the work into the next task. And here we see the next task. In this case, we don't render 2 but 3 items, 1, 2, 3, as you can see here. And then the rest of the stuff is scheduled in the next task. And if I hover over that, we see that every task here is less than even 30 milliseconds. So average size of the tasks here are between 18 and 20 milliseconds, which is amazing. This is one way how you can use Angular concurrent mode, and another way is a little bit cooler, not cooler, but more interesting, I would say. The RX4 directly renders a value, right? So we could also refactor the whole thing, and we could use another directive, the RX-let directive. This directive I introduced last year or 1.5 years, and this also basically helps us to pass an observable directly to the structural directive without using the ng flag. Pretty good, because the ng flag does not work with false values. Before I go on, let me quickly recompile and test if the app is still working and rendering. So, okay, there is some feedback, pretty good. So this could also be one way of basically applying this value to the page, and then everything that is in this container, and in our case it is the full app shell, would get rendered in a special technique in one chunk, and if there is too much, we would move the rest into the next chunk. And this is done with the value which is called here view state. But let me give you another really cool hint. If you don't want to render a value, but just chunk up the work, and here in this case I have a navigation, and in this navigation part I have another big list, and I have a lot of items, and let's say I don't want to apply any data here, I just want to chunk up this piece of logic, this piece of components. I could also use the RX-let directive here, and instead of passing a real value, which would look like this, I could also pass an empty array, basically an iterable piece that has no value. This is a small trick or hack, and with this small trick and hack, I can chunk the whole navigation, this piece of DOM here, into a separate task. And I could apply this RX-let here on multiple places as is, and chunk up my component shell. For example, I could chunk up the header, chunk up the side menu and chunk up the main content in different steps, and then I would end up in a way better performance. I could wait until the page loads, and then I could again navigate back and forth. As you can see, there is no difference, no visual difference, but if we take a look at our measurements, and maybe I can show you previous measurements, we see that there is really heavy impact. This small drop down at the top shows old and new measurements, and as you can see, my old measurement has a lot of blocking frames and my new one has only little ones, and those little ones were the ones that are left that I fixed now with the RxLed. One last demo before I hand over to the next speaker. Here we see this huge list, and as you can feel it already, it's frozen for quite a long time. Did you see that? Let me reduce the items a little bit so that you don't have to wait forever. So I navigate away. Now I click, frozen. Yeah. Click, frozen. Yeah. So this is the normal behavior, and now let me do the exact same thing with Angular Concurrent Mode, which is this item here. So I go to the empty page and then I click, back, click, back, click, back. So there is instant response. You don't even really feel any difference. And this is just because we really chunk up the work and the browser has time to breathe and the user has time to interact, tap, and scroll with our website again. This is really an amazing feature that you can directly use in your applications. You can use it in lists. You can use it for static single values with the RxLed, and you can also use the RxLed to chunk up basically any piece of DOM or component structure you like. Enough with the demos. Let me come to an end. The library that you would want to check out is called RxAngular, and we have three packages: RxAngular CDK, which is our component development kit. In this kit, we include all the strategies for concurrent rendering, all template management, and other tricks that we use. And then we have two other packages, RxAngular/template. This is where we ship the structural directives, RxLed, RX4, also the push pipe that I introduced 1.5 years ago. And then we also ship RxAngular/state, the first local state management that was present in Angular that was delivered, I guess, 2.5 years ago. So as you can see, the zoneless and performance train is a train that I'm on for quite some time now. This is only the tip of the iceberg. We already shipped a 10 features, and I will ship new features in the couple of upcoming months. But that's it so far. If you want to say thanks, especially to our contributors that did also a very, very good job in implementing and helping with those features, please go to our GitHub, RxAngular, and give us a star. We really, really appreciate it. And again here, RxAngular/templates, the package that includes all the structural directives. Have a look, check it out. It is a really, really cool thing. Next to the state management that also basically helps you a lot. And that's it from my end. I want to say thanks for your time. Thanks that you had interest on performance on non-blocking UIs. Here is a link to the repository. As I said, hit the star button and make us happy. Every GitHub star makes us more happy. If you want to contact me for performance audit, consulting, or making your product faster, more interactive, to sell better, shoot me an email or ping me directly on Twitter. I hope you liked it, and that's it.